Hello, let us solve this question on position vectors I, J and K involving internal division. The position vectors for points P and Q are 6i minus 3j plus 9k and 3i minus 6j minus 3k respectively. R divides line PQ in the ratio 1:2. Find the position vector of R and express it in terms of unit vector ijk. So there are two methods of solving this question. I'll begin with the first one. And that method that I'm going to use is on the ratio theorem. I'll begin by drawing, sketch this position vector. Remember, position vectors are vectors with reference from the origin or point O. So let me draw. So just a sketch. So assuming that this is point O, then vector P being here and Q in here. Then R divides PQ in the ratio 1:2. So I'll insert R there. So that is why I want to insert R. So the position vector of R is OR be there. So the ratio here is 1:2. So ratio theorem goes like this. So we shall take 1 as M, so M is equals to 1, then N is equals to 2. So this is how we apply the ratio theorem. M, so if you want to get OR be given by M divided by M plus N, then the vector that is opposite M is OQ, multiplied by OQ, plus N divided by M plus N, multiplied by the vector that is opposite will be OP. So this is how we use the ratio theorem. So OR therefore be given by M is 1 divided by M plus N will be 1 plus 2, which is 3. Then OQ, we're going to write OQ in form of column vector. So remember that this is Q, this one is P. So Q written in form of column vector will be 3, it will be 3. This one will be 3, negative 6, negative 3. So we multiply it that. So 3, negative 6, negative 3. Then plus N is 2 divided by the sum M plus N is 3. Then you multiply by OP, vector OP column vector will be given by 6. Then J, coefficient of J will be negative 3, 9. So these will be 6, negative 3, 9. So multiplying each of these terms here, 3, negative 6 and negative 3 by a third, you get 1, negative 2, negative 1. Plus multiply each of these 6, negative 3 and 9 by 2 thirds, you'll get this one is 4. 2 over 3 times negative 3 will give negative 2. 2 over 3 times 9 will give 6. Then we add 1 plus 4, we get 5. Negative 2 plus negative 2 will give negative 4. Then negative 1 plus 6, you get 5. So that is OR. Now if you write this one in terms of I, J and K, we'll get 5i minus 4j plus 5k. So that is the first method. So method number 2. For this method, we drawn the sketch, the position vectors of P, Q and R, inserted the ratio which R divides PQ. As you can see, 1:2 there. Now this is how you're going to get the position vector of R. So there are two ways of getting that. So OR is given by, so you want to move from O to R, you use this route. You can use OP, O to P, then from P to R, or you can use the other route from O to Q, then from Q to R. So these two methods are going to work and they'll give you the same answer. So let's choose one method. I'll use the first one. OR is equals to OP plus PR. So I already have the position vector of P. So we just write this one in column form, position vector of P, by extracting the coefficients of I, J and K. So writing that in column form, OP will be 6, negative 3, 9. So we need to get, so OP is there. So we need to get PR. And when you look at the ratio in which R divides PQ, that is what is going to help us. So PR will be given by a third. That is internal division. So this is 1:2. So PR will be 1 divided by the sum of the ratio, that is 1 plus 2, PQ. So PR is equals to a third PQ. So from here we get 1 over 3, that is a third. Then PQ plus to get position the vector PQ. How do we get PQ? We get PQ, the easiest way to get PQ is by taking OQ minus OP, since these are position vectors. So PQ is equals to OQ minus QP. Or you can also, you want to move from P to Q, so you can go this way, PO plus OQ, which is still the same thing. So whether you use this method to get PQ or use this one, still the same. So let us proceed. So this will give 1 over 3 OQ, the vector, position vector for Q. Write this one in column form, 3, negative 6, negative 3. Subtract OP is here, 6. We are extracting the coefficients of I, J, and K, 6, negative 3, 9. So this will give 1 over 3 multiply by, when you subtract 3 minus 6, you get negative 6. So this will give a negative 3. 3 minus 6, negative 3. Negative 6 minus negative 3 will give negative 3. Again, negative 3 minus 9, negative 12. So this means you multiply each of these terms inside here, negative 3, negative 3, negative 12 by a third. Each one of them by third. This will give negative 1, and negative 4. So now we have PR. We have PR. So therefore, OR is obtained by taking OP which is 6, negative 3, 6, negative 3, 9 plus PR. You already got PR. PR is here, negative 1, negative 4. And when you subtract these, 6 minus 1, you get 5. Minus 3 minus 1 will give negative 4. 9 plus negative 4 will give 5. So you can still see you're getting the same answer. So writing this one in terms of IJ and K to be 5I minus 4J plus 5K. So those are the two methods